Somewhere right now, someone's heart is stopping. Not dramatically. No slow-motion collapse, no orchestra swelling, no one yelling "Nuo" in the rain. It's disappointingly undramatic, honestly. One beat. Then nothing. Blood pressure falls to 0 almost instantly, which, for the record, is the single worst blood pressure reading you can get. 5 liters of blood that were sprinting through you a second ago are now just sitting there, like commuters when the train breaks down. Going nowhere. Mildly annoyed. No pump in sight. Your brain, meanwhile, has no idea any of this is happening. Blissfully out of the loop, like a coworker on vacation while the office burns down. For roughly the first 10 seconds, it's still coasting on whatever oxygen was already in the blood. Running on fumes, but running. Neurons keep firing. Thoughts, whatever they were mid-sentence, just keep going. You are, in every sense that matters, still you. But that window is short. And it's already closing. Here's a fun fact your brain would probably find rude. It eats up about 1/5 of your entire body's oxygen supply. More than any other organ. Sorry, liver, better luck next time. So when the deliveries stop, the brain notices almost immediately, like someone who orders one Amazon package and starts refreshing the tracking page every 4 minutes. Around the 10-second mark, the cerebral cortex, the seat of conscious thought, begins shutting down. This is usually where people lose consciousness. Eyes stop processing light. Ears stop registering sound. From the outside, it looks like the lights went out. From the inside, that might not be true at all. In 2023, University of Michigan neuroscientist Jimo Borjajan published a study that watched 4 dying patients closely as they came off life support. Not exactly a fun Tuesday at the lab. The expectation was a slow fade. Activity winding down gently, like a phone battery easing its way to 0. That is not what happened. In 2 of the 4 patients, the brain did something nobody predicted. It surged. Gamma wave activity spiked to levels far above normal waking consciousness in at least 1 patient. Gamma waves. The same signature linked to focused awareness, memory, and dreaming. Basically your brain's "I am extremely locked in" setting, showing up at the worst possible time to show off. And this wasn't random static either. The activity concentrated specifically in the temporoparieto-occipital junction, a region already linked in earlier research to out-of-body sensations and visual processing. That's where the clean, tidy science politely exits the room, and the much weirder questions walk in. For decades, people revived from clinical death have described things that sound a lot like what a surge like this might produce. Bright light, a sense of drifting above their own body, a calm that's oddly hard to put into words. Then there's the life review, and here's where most people get it completely wrong. You're picturing a highlight reel, aren't you? The wedding, the birth of your child, the trophy moment, nope. Turns out your brain, in its final act, isn't interested in your greatest hits album. It wants the B-sides. Riding a bike as a kid. Answering some forgettable email on some forgettable Tuesday. A white cat sitting on a staircase you don't even remember. That last detail is real, by the way. A young man resuscitated after clinical death described exactly that. A staircase, an apartment, a white cat, from a building he had absolutely no memory of ever entering. He was 14 months old the last time he was there. 14 months. At that age, most of us can't remember what we ate for breakfast, let alone the interior decorating choices of an apartment we haven't seen since infancy. When he described it, his mother confirmed every single detail, right down to the neighbor who actually owned that cat. So somewhere, a cat is very quietly famous in the neuroscience literature and has no idea. Whether the dying brain can unlock memories you didn't even know you had is a question neuroscience genuinely can't answer yet. But the brainwave data makes one thing clear. This is not a simple shutdown. Meanwhile, the rest of the body is having a much less poetic time. No gamma wave light showdown here, just chemistry doing chemistry. Around 30 seconds in, the blood has stopped carrying oxygen anywhere at all. All 37 trillion of your cells, yes, trillion, your body is basically a small country's population of cells, start switching from aerobic respiration to the anaerobic backup version. It works. It's just messy, It floods your system with lactic acid, like the world's least fun workout you never agreed to do. Muscles that no longer hear from a functioning brain go slack. The jaw drops. Eyelids stop holding themselves shut. Pupils widen and freeze in place, the tiny muscles that once adjusted them simply gone quiet. Your eyes are still there. Whether anyone's still behind them is exactly the question researchers have spent years chasing. Dr. Sam Parnia, a resuscitation researcher at NYU, has spent more than 2 decades on that exact question. 2 decades? Most people can't commit to a gym membership for 2 decades. His AWARE studies, the largest research effort of their kind, have tracked cardiac arrest patients across 25 hospitals. In the AWARE Roman II results, published in 2023, close to 40% of survivors reported some perception of consciousness during the time they were clinically dead. About 20% described what researchers now call a recalled experience of death: structured thought, clear memory, a real sense of awareness. And roughly 3% reported full visual and auditory awareness. They could see and hear, despite showing zero outward signs of a working brain, which is either deeply profound or the most elaborate game of possum in medical history. Science hasn't fully decided. One detail comes up again and again in these accounts: the feeling of not being alone. People describe a deceased relative appearing, a grandparent, a parent, seemingly there just for them. Some say they were told it wasn't their time yet. Others say they were simply guided. Whether that's the brain generating one last, comforting story on its way out, or something science genuinely hasn't caught up to, that's still unresolved. What the data does consistently show is this: for most people, dying isn't reported as frightening, not dark, not empty. Usually, weirdly, it's described as peaceful. And naturally, that peace is exactly where scientists decided to start arguing. Earlier this year, an international team proposed a sweeping framework called Neptune, aiming to explain near-death experiences purely through known neurophysiology. Basically, it's all just brain chemistry, nothing to see here, please disperse. Researchers Bruce Grayson and Marietta Pelivanova pushed back hard. They argued the model conveniently skips the parts that are hardest to explain away: verified out-of-body perceptions, encounters with relatives whose deaths the patient didn't even know about yet, and permanent shifts in how survivors see life afterward. Grayson has said plainly that neurophysiology alone can't yet account for these experiences, and that the search for an answer is far from over. Other researchers have thrown their own theories into the ring too. One recent idea suggests sensory signals just misfire together under extreme stress, producing something that feels completely real even though it isn't. So basically, nobody agrees, everybody has a PowerPoint, and the debate is very much still open. Back to the body one more time. At around 60 seconds, cell damage is becoming serious. But here's the important part: it isn't permanent yet. That distinction matters enormously, because this is still a window where resuscitation actually works. CPR, a defibrillator shock, and there's a real chance to pull someone back. Brain cells can typically survive 4 to 6 minutes without oxygen before the damage becomes irreversible. So at the 1-minute mark, you're sitting in a genuinely strange biological in-between. Not alive in the usual sense, but not gone for good either. Inside your cells, enzymes that were safely sealed behind membranes start leaking out as those membranes weaken under the acid buildup. This is the start of autolysis, a delightful word that basically means your cells are quietly starting to eat themselves from the inside. Either horrifying or the world's slowest, saddest buffet. But at 1 minute, most of the body is still intact. Still waiting. Waiting for what, exactly? There are 2 honest answers, and both are true. Medically, the cells are waiting for oxygen. Restore blood flow within the next few minutes, and many of them recover completely. It happens in hospitals every single day. But if nobody comes, no CPR, no defibrillator, no intervention, then this was the last minute of a life. And based on everything researchers have gathered so far, the gamma wave data, the survivor interviews, decades of resuscitation studies, the brain doesn't appear to spend that final minute shutting down quietly. It spends it lit up. Here's the part that always gets me. The people who make it back rarely talk about wanting more money or more status, or a bigger house. Nobody comes back from clinical death going, "Man, I really wish I'd bought more crypto." What they say they want is more time with the people they love, and more attention paid to the ordinary moments they used to let slide right by. Because those, it turns out, are the moments that come back to you at the end. Not the milestones, not the highlight reel, the unremarkable Tuesday afternoons. The ones you never thought anyone was keeping track of. Your brain was keeping track of all of it. And in your final minute, it may just play the whole thing back.